So this is part 2 of the 6th grade Geometry Standards video series, and we'll look at task number 8, where we're dealing with, again, the volume of a rectangular prism, but I'm actually giving you the volume this time. So we've got volume equals the length, width, and height. So the volume of the prism is 21/12 cubic feet. You can simplify this if you like. Divide 21 and 12 both by 3, and you would get 7/4. You can leave it as 21/12 if you want to. We know the height of the prism is 3/4, but we don't know the length and the width, which is also called the base. So when you're thinking that rectangular prism, if it's wanting to know the area of the base, it's that length times width. So we don't know what the base would equal. We do know the height is 3/4, and we know that the volume is 7/4. So one way to do this is we could divide both sides by 3/4, since the denominators are the same. This is a nice division of fractions. 4 divided by 4 in the denominator is 1. 7 divided by 3 in the numerator would give us 7/3 square feet, since it's the base. So that's one way to look at that. And then again, another way to look at it was if you had 7/4 is equal to the base and you're multiplying it by 3/4, you could use your reciprocal and multiply both sides by 4/3. And so 3/4 times 4/3, since anytime you multiply a number by its reciprocal, you're going to get 1. So this goes to 1, and you're left with the base is equal to 28/12, which both are divisible by a factor of 4. So that would be 7/3. Another question is if we know the volume of a rectangular prism is 10/12 and the area of the base is 2/3, what is the height? So this is where we can take 10/12, we could divide by 2. Factor of 2, so 10 divided by 2, that'd be 5. 12 divided by 2 would be 6. We can do the reciprocal rule if we want to. That would be multiplying both sides by 3/2. And that means this would go to 1. And so we'd get 15/12. And this would be feet. And 15/12 could be simplified. Divide 15 by a factor of 3 to get 5. Divide 12 by a factor of 3 to get 4. So we would get 5/4 feet as the height. Another part of this task is where we want to determine the volume of the space in the tank that needs to be filled if the water's already 1/3 foot deep. So you're not worried with the water piece, you're just trying to figure out what's left over. Well, there's some different methods here to do this. For one, we could figure out the volume with the water. Okay, so that volume would be 5 feet multiplied by 1 2/3, which would be 5/3 if we change that. And then the water is 1/3 deep. So this would be 25 thirds. If I look at just these two fractions, that'd be 25 thirds times 1/3. That volume would be 25 ninths cubic feet. Now that's just the area of the water. Now if we find, no, I'm sorry, and I said area, that's the volume. That would be the volume of just the water. So now what we can do is we can find the volume of the entire tank. And so the entire tank would be 5 times 5 thirds times 2. And that would be 25 thirds times 2, or 50 thirds cubic feet. Now, if we want to find the space in between, then we would take the volume of the tank, which is 50 thirds. We would subtract the volume of the water, which is 25 ninths. So we need common denominators here. So we could multiply this by 3 and this by 3. So we'd get 150 ninths, take away 25 ninths. So we would have 125 ninths cubic feet as the volume of the space that needs to be filled. Now we can also look at another way to do this. And so if you know that it's 2 feet high, right? The prism is 2 feet high, but we know that it's 1/3 foot deep. Well, so that just means that if we know it's that height was 2 feet and we had 1/3 foot deep, so what's 2 take away 1/3? That's going to be 1 2/3. So this is now looking at the space or the height of the space that we're looking for. So that would be 5 thirds as the height. And then the width would be another 5 thirds, which is 1 2/3. And then, of course, the length is 5. So if we multiply this together, we're going to get 125 ninths cubic feet, which is also the area, which is what we found in the calculation before. So the only difference was this 5 thirds, because I took 1/3 away from the 2 foot height to give me 1 2/3, which is the same as 5 thirds. All right, task number 10. This was one that I'd mentioned in the previous video called packing cubes. And here we've got this cube that's a 1/4 by 1/4 by 1/4, and we're just trying to figure out how many of those would fit in the prism. So I want to figure out what's the volume and then how it's going to be measured. So what we want to look at is we have a length that's 3 3/4. We have a width that's 3 feet, and we have a height that's 3 1/4. And we have a prism, a small prism that's a 1/4 by 1/4 by 1/4. All right, since everything in the shipping box has a denominator of 4, at least 2 dimensions, what we're going to do is go ahead and change the length and the height to how many fourths. So the length would be 12 15 fourths. the width would stay 3, and the height would be 12/13. So with the length, we're just trying to figure out how many 1/4 would fit across that length of 3 3/4. And that would be 15 cubes. Now the width, we've got 3 feet, and we're trying to figure out how many 1/4 would fit across. That could be 3 divided by 1/4, or 3 times 4, and that would be 12 cubes. The height is 13/4. If we divide that by, we'll be able to find a height of 13. So what we're looking at here is just trying to figure out the volume. And so we've got a length, width, and height. And so we've got 2,340 cubes. That would be 1/4 by 1/4 by 1/4. But we also have the volume of the smaller cube. So what we've got is 1/64. 1/64 cubic feet would be the area, or excuse me, the volume of the fish food. And so what we're trying to do is just figure out, well, if this is the volume of the shipping box, and we divide that by 64, which is the same as multiplying by 1/64, which is the volume of the fish food, we're going to get about 36, approximately 36.5 cubic feet as the volume. Okay, so just skipping ahead of that, let's look at the next task, task number 11. We want to look at nets. Okay, so this will be something that's the net portion of this is just the two-dimensional. Now we're starting to talk about surface area. And so you can see 6.G.4, we're looking at three-dimensional figures, but we look at the nets, and the nets may be made up of rectangles or triangles in order to help find the surface area. So to the right, we have a net for a three-dimensional shape, and notice that we have, it says we have the inner quadrilateral is a square, and then we've got 1, 2, 3, we've got 4 triangles that all have the same area and the same shape. So if we were looking for surface area, abbreviate here, S dot A. So surface area, we know that we're looking at a square, and then we know we're looking at 4 triangles that have the same area. So that's kind of how you're thinking about figuring out the surface area. All right, so what do we know? The three-dimensional shape, okay, what three-dimensional shape does this make? So we want to look at, well, what is this base? What's that base shape? Well, we said it was a square. And notice that when the 4 triangles come together, they come together at a point, right? So when they come together at a point, we're thinking of a pyramid, okay? So we name pyramids by their base. So this is what we would call a square pyramid. You can have rectangular pyramids, square pyramids, pentagonal pyramids, triangular pyramids. Notice all of those are just about naming the base. So let's say that the length of the sides of the square, they're 2 by 2. So we know that the square, in order to calculate the surface area, is going to be 2 by 2, which would be 4 square units. Now the triangle, we better know a length or a base times height, but we know we've got to divide it by 2. So the base of the triangle we know is 2, and we say that, and we also know that the height of the triangle is 3. So that's what we're looking at right here. So that height. So that would be 6. But we got to cut that in half, divide it by 2. So we're going to get 3 square units. So what we have for the surface area is that we have 4 square units plus 3 times, since 3 is the area, and there's 4 of those triangles. So we've got 12 plus 4. Surface area should be 16 square units. And so that's just breaking down the surface area, and that's what I would encourage you to do. We have surface area formulas for prisms or a cube. We can look at that, but when you're looking at prisms, pyramids, and different types of pyramids, you want to just kind of break that down into how many triangles do we have? What's the area of one triangle, multiply it by how many triangles you have, and then we want to add in the area of whatever the base would be. Task number 12 is more of just matching that shape of the 3-dimensional with its net. So over here we look at, well, that's going to come to a point, right? So that's going to be your pyramid. And notice the base is a rectangle or a square. And so we notice that these two would go together, okay? And then we see triangles here, and we see triangles here. So this is a triangular prism, and this is the net of the triangular prism. And then finally, what we have is just a general prism, and this would be the net that would go along with it. So the net, you're just unfolding it. As I told my 6th grade son last year, I said, take the cereal box that we have, just unfold it, and we see all of the different rectangles that make it up. But when you piece it all together and you glue those pieces together, you've got a rectangular prism, which holds the cereal package. But when you unfold it, you've got all these 2-dimensional shapes. And interesting enough, these cereal boxes or Pop-Tart boxes or cracker boxes or anything that they never look exactly like this, because you've got glue and you've got overlap. You've got different pieces that make up. So it's not a perfectly, to a prism like that, the surface area is not exactly pictured like that. All right, task number 13 here's where I want you to create the net. So if you have graph paper, and I'll have graph paper in the student notes, so that's something that you can print, or you can always print free graph paper, or you can go get some graph paper if need be. But putting a net on the graph paper is really helpful, because you can, especially centimeter graph paper. And let's say that these are measured in centimeters. So this is we've got a length of 3, a width of 7, and a height of 6. So I'm going to use my line tool, and I'm not measuring exactly, but I do want you to see that I'm going to start with the base, but I want you to kind of get this picture of how this looks in the background. So it's looking something like that. If I add in some of those background pieces, or I can use a dotted line just to see that. So you can kind of see through that, make it a little more transparent. So I'm going to start with the base, and I have different colors so I can kind of highlight the different pieces here. So if I start with the base of a 3x7, I'm going to go ahead and label that. So that's 3x7. There's the base. I know that what I'm going to have is a side, which is a 6x7, but I'm going to have 2 of them. Okay, so you see those pictures, I've got both of those. So I need to draw this length, which would be a 6x7. And I need 2 of them. And I don't have my exact measurement, so it might appear to be, I'm labeling them so you know that there's going to be 6x7s. And so you see that on the net, and then here on the 3D, you can see the 2 sides that are red, so you can see them here as well. So I've got 3 sides, and I need to see 6 sides. So I'm going to use a different color of green, and I want to look at the top pieces. Well, I've already drawn the base, right? So this green one, I guess I probably could go with blue. And so you would see that the blue on the top should model or should mirror the one on the bottom. So what I'm going to do is come over here to the side, and there's my 3 by 7. So there's my 4, there's 4 of my pieces. And then you have you've got this front face, and then you've got where would be another one, which would be in the back face. So there's 2 more. And so those kind of come off of that 3 by 7. Which would be, they're both going to be a 3 by 6. So remember, this is just kind of that estimate of a drawing there, but there's going to be my 3 and my 3. This would be 6, and this would be 6. So I see my 6 sides. It's always good if you can use different colors, especially for students to be able to see that. It's very important, the visual part of mathematics. So if I want to calculate the surface area, here's what I know. I've got green, which means I've got 2 of those that are in green. Well, what are they? Well, there's 2 of them that are 3 by 6s. And then I've got the red. And there's 2 of the reds. And there's 2 of the blue. Well, the reds are going to be 2 of them, and they're 6 by 7s. And then the blue, there's 2 of those, and they're going to be 3 by 7s. So to find the surface area, you're basically going to take the sum of all those products. So with the green, you have 18 times 2, because the green is a 3 by 6, so 18 is the square units, but I got to double it. So that's going to give me 36 square units. Red, there's 2 of the reds, and they're 6 by 7, which is 42, but I've got to double it. So that's going to give me 84 square units. And then the blue is going to be a 3 by 7, and I've got to double that. So that's going to be 21, double it, I'm going to get 42 square units. So like I said, I just need you to add all those up. And that should be 162 square units as the surface area. All right, in our final task, number 14, we're going to look at 2 different nets, and I want to figure out the expression that I could use to find the surface area, and then I want to actually find the surface area. So notice I've got 4 triangles plus 1 square. So the expression could be 4 multiplied by, well, what's my base? 4. What's my height? 3. I'll do 4 times 3 divided by 2, plus there's 1 square that is a, what, 4 by 4? So that would give me the surface area, which would also give me the expression. So this piece right here would fall into what would be your expression. So the surface area, to just calculate that, that's going to be reworking here. So I'm working in the parentheses. So 4 times 3 is 12. 12 divided by 2, that's going to give me 6. So the area of each triangle would be 6, and there's 4 of them, plus 1 square of 16 square units. So that's going to be 24 plus 16, and that should be 30 and 10, 40 square units for the surface area. So the expression is good to build because you know you've got to find that surface area, so you're working that expression and creating that expression in order to find the surface area. All right, so next we have, looks like we have 1, 2, 3, 4, 5. So we have 2 5 by 5s, because this is number 1 is a 5 by 5, number 2 is a 5 by 5. So we have 2 of those, so that's why I'm writing 2 multiplied by 5 by 5. Plus, we have, so this one is a 2 by 5, this one's a 2 by 5, and this one's a 2 by 5, and this is another 2 by 5. So we actually have 4 2 by 5 rectangles. So that would be our expression. And in order to find our surface area, 5 times 5 is 25, double it, I get 50 for the 2 big squares. And then 2 times 5 is 10 times 4, so I get 40. So my surface area would be 90 square units. So with this last part of the part 2 of our video series, we did look at some different volumes, and you were given volumes and you had to find maybe the base, you had to find the height, so we were kind of working in reverse, or you were given the packing cubes one where you were given the length, width, and height in a fractional notation, and you were given the smaller cube in a fractional length, trying to figure out how many of those would fit in to the package to find the volume. And then we looked at nets, and we looked at surface area, and we looked at different types of three-dimensional figures. So breaking down those three-dimensional figures into nets and finding surface area was the last part of this. So this concludes part 2 of our 6th grade geometry video series.